Welcome to our third video in this series of using C# and Godot to dynamically create and modify a mesh in 3D. In our last video, we dynamically created a wireframe around a cube so that we could look at the structure of it. And I mentioned in the last video that we probably are going to go at least one more video. Most likely we're going to be going two more videos of not quite yet modifying the mesh of the cube. What we need to do now is we need to have the ability to rotate around our environment so that we can actually look at the cube from different angles. So in this video we're going to cover keyboard input, mouse input, and most likely we're going to be adding some lights to light up some of the darker ends of the cube here. So the first thing I want to do before we do that is you notice in our scene tree here that things are just kind of grouped. Well, they're not grouped at all. They're just all under main. And I want to start grouping these under nodes so that we have a little bit of an organization, because as we start adding more lights, this list is going to get larger and it's going to become, well, it's going to be hard to look at. So in Godot, since we know we can create child items of parent nodes, there's a certain value in using a node to kind of group underneath it, kind of like a folder in a file structure. And I think the easiest node to use for this is going to be the most basic node you can get, which is a node. So what we're going to do here is we're going to create a node. There we go. And what we're going to do here is we're going to call this meshes. And then we're going to move our cube and our floor under meshes. And then you can see, you can close it up to make it a little bit easier to view. And then so what we're also going to do is we're going to go ahead and create another node, and we're going to call this one lights. And we're going to move our directional light under there. Now right now we only have one light, but we're going to be adding more and it'll just make this easier. Plus we can just close this thing up and not worry about it. And we're going to do something with the camera in a little bit here, but I'm going to leave it out just for now so that I can demonstrate what we're going to do as far as the rotation, and then we can move it under its own little place. Now if we tried to run this code as it is, this would actually not work. And the reason it wouldn't work, I guess there's value in hitting the play button. The reason it wouldn't work is because we now moved the cube under this meshes node, and our script is on the main node. So when it's trying to find the cube node, it's only looking for the child. I'll show you what that means here. Let me make sure. Let's see if debugging is actually on here. It's not, so awesome. So I'm going to run this and it should fail. And it does. So if you go here and then here, you'll see that it's not able to find the cube. And that's what I predicted was going to happen. And the reason for that is in our code up here, we're just getting the path of cube. And when one does a path like this, where one just lists the name of the object one's looking for, the node, it looks directly under the children, and that's it. It doesn't go down to the grandchildren. So what we need to do is we need to tell it to look under that meshes node that we created. So if we just do this, meshes/cube, think of this kind of like a file path. So if we run Godot now, this should work. And it does. Okay, so I guess the next thing to do here is as we start doing stuff, this window is just a little bit, the game window is a little bit too small for me. So let's actually go and make the window a bit bigger. So if we go to display window, there's this width and height fields. So we're going to make this 1080p. So we'll close it. And now if we hit the play button, the window should be much bigger. Okay, so this will be much nicer for us to work in. So the next thing here is, so what I'm going to set up as our keyboard mechanism for rotating is I want to have it so we're going to tap the Alt key, and then as we're holding down the Alt key, if we drag the mouse, we're going to rotate around the scene. And then if we let go of the Alt and just move the mouse around, nothing's going to happen. So what we're going to need to know how to do is we're going to need to know how to grab keyboard input, grab mouse input, and then process that. So going back to the Godot documentation, first thing is if one looks at the page for a node, you know how right now we are putting everything in this ready method, and this is probably not what we would want. In fact, there's no probably about it. This is not what we would want, this all jammed in this one ready method, if we were doing this for any larger project. But I'm just jamming it in here for right now because it's simple. And if you look at the node web page on Godot and you look at what's here, it lists all of these kind of lifecycle methods. Here's the ready. And so what we're going to want to do is we're going to use this input one. Now I did read that there's also this unhandled input, and this unhandled input seems like it's probably what one would use if we were overlaying GUI elements and we wanted to have different things capture certain events, but then if nobody captured anything, to have this finally capture it. But I don't think that's, I mean, this thing we're building is so simple that doesn't seem like something that I'm going to pursue at this point. But I'm going to use this input method, and then this is going to go ahead and be called every time there's a method. So what we're going to do is we'll go back to Writer, and we want to create that input method. So let's go to Writer, and we're going to put the cursor at the top of this class because I want this new method to appear there. And we're going to right click, and we're going to click on Generate, and we're going to click on Overriding Members. Yes. And then it lists all these things that node that one can override. And what we're interested in here is input. So we're going to hit the OK there, and we're going to hit OK. And it creates kind of the base stub for that. Now I'm fairly new learning C#. As I said in my first video, I'm a Java developer, or at least, you know, I've done decent work in Java. And so luckily the C# syntax and a lot of the concepts are very similar to Java, but some things are a little bit different. And the first thing when I did this is I saw this input method that had this input event parameter, and then it had this @ event, and I wasn't really sure what that was. And so I had to research that, and it turns out that event is an actual reserved word here. So if you put @ in front of a variable that's a reserved word, you can use it. So it's kind of like saying, I'm going to make a variable called integer, and I'm going to call it if. See, in theory, if you didn't know about that @ this wouldn't work because, well, if is a reserved word. But if you make your variable that, then you can call it that, and that's what's happening here. Now, because I'm not used to that syntax, and I really don't want to be dealing with that as I'm processing the event, what I'm going to do is just rename that to something that's not a reserved word. So if one right-clicks on the variable and clicks refactor and then rename, one can rename this. And if one uses the refactoring in Writer to do this, you notice not only did it change it here, but it changed all the occurrences of using it. In this case, there's only one. But that's a nice feature of using an IDE like Writer, is refactoring code like this, where you're, in this case, it's a simple refactor of just renaming it, but the IDE has a lot of convenience ways of doing things. So then the next question was, like, this line here is basically saying it's passing this input onto its base class. It's going up the hierarchy and it's passing the event. And I wasn't sure if this should happen at the beginning or the ending of this method. And I'm going to say it's going to happen at the beginning, so I'm going to leave it at the top of this method. So what we want to do now is we want to go ahead and we want to capture some keyboard input. And I think the way we want to do that is we want to see what kind of event it is first. And then based on the event, whether it's a mouse event or a keyboard event, we want to do something with it. So I'm going to go ahead and use a switch for this because I think it's the cleanest way to do this. And I'm going to go ahead and I'm going to switch on the event. And then I'm going to go ahead and I'm going to create a case for if it's a key event. So if it's a key event, well, I want to print out what the code is. You're not going to get the character back. You're going to get a scan code for it. And I guess I should show that. It's not there. It's here. So these codes are, especially when you're talking about the alphabet, I mean, they're very like Unicode or ASCII-like. So like, you know, A would be capital A 65, 66, 67. So that's what you're going to get back when you check for the key. But it's pretty easy to map it back and forth. So in your code, you can check what key is pressed. So what we're going to do is at first we're just going to print out the scan code, and then we'll check for specific keys in a minute. So you pressed, and we'll do input event key dot get scan code. Okay, so let's go ahead and run this. And so down here it'll display, I guess that's the downside of making the window bigger, is it might, yeah, it's going to obscure that a little bit, but that's okay, we'll move it up. Okay, so I'm going to press lowercase a, see how it appeared there. Uppercase A has shift and then A. You know, you're basically seeing, as I'm pressing different keys, you're seeing it twice. You're seeing it once for it being pressed and once for it being released. So we're getting the key code. And I think I want to have the Alt key be held down while we're moving the mouse. So now we want to check to see if the Alt key is pressed. So the way one would do that is going back to Writer. Let's get rid of this. So inside here, I think I'm also going to have another kind of a switch inside the case statement, because for different keys I might want to do different things. So what I'm going to do here is I'm going to switch on input event key dot get scan code. And what I want here is I want a case, and then an easy way to check if a certain key has been pressed. I mean, you could know those numbers if you want, or you can use this key list, and this key list you can pick, you know, what key you want. Like there would be an A, but in our case we want to know if the Alt was pressed, so we'll do that, and then we'll do that. Now you notice it's being underlined, and that's because it's having trouble going between what this is, which I think is an enum, and an int, but in the end they're going to be the same thing. So if one just casts this to an int, that goes away. So what we want to do here is we want to say gd print, now print, and we want to say you pressed Alt. So let's go back to Godot. Let's run the game. And so now we shouldn't get any text on the console here unless I'm pressing Alt. So I'm pressing A, S, F, G, J. None of these nothing's happening. But if I press Alt, well, see, one for up, one for down. See, up, down, up, down. So now we only want to have it. We're getting the Alt now, but now we only want to have it for when it's being pressed, not when it's being released. So when I tap it, I only want it to display you pressed Alt once, and not when I release it. So we just have to go and modify this just a little bit. So what we want to do here is we want to check to see if it's pressed. So basically, if input event key dot is pressed, if it is pressed, then we want to print you pressed Alt, but it's not going to. Well, actually, let's. So we're going to have it so it'll print you pressed Alt, and if you didn't press it, then you've released it, so it's you released Alt. So if we go back to Godot and hit the play button, and then we drag this so we can see. So I'm going to press Alt. I notice I'm holding it down, so it's doing it multiple times. We can fix that. Then if I release Alt, watch what happens. See? So it says you released Alt. Okay, so we're almost there, but I don't want it to, as I'm holding down Alt, I don't want it to keep saying, oh, you pressed it. I just want to know the first time you pressed it down and are holding it. And so what one would do is, so let's get rid of this released because we don't really care about that anymore. And so we're checking to see if it's pressed, and we want to make sure it's only the first time it was being pressed. So what there is there's this method called IsEcho, and if one reads here, it says if true, the key was already pressed before the event. It means the user is holding the key down. So if we go ahead and do an AND here, and we say input event key dot IsEcho. So what this would do is this would display this message, not the initial time you hold down the Alt key, but the subsequent time. Well, we don't want that. We only want it the first time. So we want to not this because we want it when it was not an echo. So it would be the Alt key the first time you're pressing it. So if one runs this in Godot, I would expect this to be what we want. So let's look in the console here. I'm going to press and hold Alt. I'm pressing and holding Alt. It's not displaying it anymore. I let go of Alt. I'm going to press and hold Alt again, and it's displaying it one message, and now I'm letting go of Alt. So that's what we want. So fantastic. So now what we want to do here is we want to, we know we can detect the Alt key, but we probably want to set this we want to have this so that this is set for the actual object here, so that as we're moving the mouse, we're going to be able to know if the Alt key is pressed, and there's no easy way to do that. We're going to need a variable to do that because we haven't checked for the mouse code yet. I guess we could do that. Let's do that next. Put an area where we're going to detect for the mouse event. We just won't do anything with it. So what we're going to do here is we're going to create a case, and we're going to create a case for an input event mouse. Input event mouse. Okay. Now we're not doing anything in here, but if the event coming in, which will be us moving the mouse, this will be the case that will happen here. But we're not going to be able to know if the Alt key is being held down the way it is now. We need some other variable somewhere that we can use. So what we're going to do is create a member variable to keep track of that. So what we're going to do is we're going to create a private Boolean variable called is Alt pressed, and we'll initially set it to false. And this is another, it's not so much a C# convention. C++ uses something similar. When you're doing member variables, the naming convention, it doesn't have to be this. You could not do this with the underscore. You could just call it that. But the naming convention in C# is to put an underscore in front of the variable if it's a member field. And I think like in C++, I think this is a convention, putting M and underscore and then the variable. But we're obviously not going to do that. But we will follow the convention of using an underscore for the member variable. So we have this, Alt pressed is now set to false. So inside here, what we want to do is we want to set that equal to true. But then it's like, we're going to need to keep track of when it's released and when it's held down. And we're going to have to do an if-else there. And there's probably an easier way to do this. So let's just go up here and let's actually say is alt pressed equal input event key dot is pressed. So now we're going to be setting this based on whether it's a release or a press. So given that, we don't need this call again. We could just say is alt pressed. And we also don't need this anymore because that's already set. So functionally this shouldn't do anything different when we run it in Godot, but now because it's up here in a variable, we know if alt was pressed and is being pressed. When we get a mouse event, we'll just be able to check that variable out in C. And before we move on to that piece, let's run this and just make sure it's doing what I think it's doing. So we're building the solution. Opens the window. So I'm going to press and hold Alt. And you notice it printed it once and only once, and I let go. Press and hold Alt again. Now I'm releasing. So that's what happened before, but the code changes we made at least didn't break that. Okay, so now we need to be able to, we know if the Alt key is being pressed, but now we need to start tracking the mouse motion. And we only really care about the mouse motion when the Alt key is being held. But let's go ahead and just, whenever the mouse is moved, let's just display the mouse position. Just like we did with the key, let's start simple and build our way up. So what we're going to do is in this area where it says input event mouse, we're going to do some checking here. So what we're going to do here is, well, actually we won't even check, we'll just print. Let's print mouse position equals, and let's spell mouse correctly. And we're going to do the input event mouse, and it has a method that's called getPosition, and it's a vector 2. And for right now, that's going to be sufficient. So this is, whenever we move the mouse, it's going to display the mouse coordinates. But I want to show what the mouse coordinates actually are, and it'll be easier just to show it. Okay, so I'm going to start the thing here. Because if one doesn't know how the window coordinates are working in Godot, this can be confusing. So up in the upper left corner, this is 0, 0. So when I move the mouse into the window, you're going to start seeing coordinates here that are fairly low. So we're at 12, 50, 60, 90. You notice the X is going up as I'm moving to my right. And then if I move down, then the Y coordinate is getting larger. And if I go to the bottom right corner, we're getting close to the 1920 by 1080 that I set the window to. So the secret here is 0, 0. A lot of times people would think it's here based on high school Cartesian graphing, but for these windows it's actually up here. 0, 0 is up here. So we're getting the mouse position. So basically what we want to do here is when we tap the Alt key, we want to store our mouse position. And then as we're holding the Alt key down, or as the is Alt key is pressed is still true, we want to track how much has changed from when we first pressed the Alt key, the position, to where we are now. So like, like right here is like 679 by 710, but then as we move it, we don't want to track, it's not 726 that's changed in X, it's just the difference of when we click the Alt key versus now. And hopefully that makes sense. So what we're going to want to do is we're going to want to, as we tap the Alt key, we're going to want to have to store the mouse position at that time. And that's actually not too bad. So what we're going to want to do here is, much like the we created a member variable for isAltPressed, we're probably going to want to have the a member variable for the position of when we started, I guess we'll say, dragging. So we're going to create another member variable, and it's going to be a vector2, and it's going to be starting with an underscore, and we're going to call it start dragging position. So this is going to store the coordinate, the vector2 of when we press the Alt key. Well, when do we press the Alt key? Well, we press the Alt key down here. So what we want to do here is we want to then set start dragging position equal to what? Well, down here we used there was an input mouse event, and the mouse events have this get position method. Well, the key event doesn't have that, so we can't use that. But every node has access to the viewport. So what we can call is we can say get viewport, and on that we can call get mouse position. And as you can see here, it returns back a vector2, which is what we want. So there's two ways we're getting the mouse position. We're doing in the mouse area, we're getting it from the mouse event. But in the keyboard event, we don't have access to the mouse. All we know is a key was pressed. So luckily, we can query the viewport and say, hey, where's the mouse pointer at? And that's what we're doing here. So what we're going to do here is let's print out. Actually, let's not print it here yet. Up here, let's just print you pressed Alt with starting position. I don't know why I'm having trouble spelling that. Okay, so when we press the Alt key now, it's going to tell me I pressed Alt, and then it's going to tell me what the starting position is, which is stored in this member variable. So let's go back up to Godot and press the play button. And that's the thing why one needs to kind of do this very incrementally. I mean, unless you're really good and really experienced at this particular thing, which I am not, it's so easy to make mistakes trying to do the solution all at once. But when one builds slowly up and verifies that at each stage it's working correctly, then it's easier to get to harder and harder solutions. So let's move this up a little bit. So we're getting the mouse pointer. So like right now we're at 1451, I guess. So if I tap the Alt key, so you'll see you pressed Alt, the starting position is at 1451 by 271. So that's fantastic. So like as I'm moving this a little bit, like I'm at 1471 now, and I started at 1451, so the change in X was 20, and that's what I want, is the 20. I don't want the absolute position, but I want how much has changed since I pressed the Alt key. And the reason I want that is because I'm going to be holding down the Alt key and then dragging my mouse, and then the camera is going to be rotating around the cube, but I have to tell it how much to rotate. And the mouse position, the mouse change based on from when the Alt was pressed to where I am, that's what's going to determine whether it's going to move left, right, or what have you. So now we have the code in place to actually detect the Alt position, the Alt key, the mouse position. But now we want to know what the distance is that was being dragged, and by distance I'm kind of using that in quotation marks. But because we're only really caring about the x value, because we're not doing anything if you move the mouse up and down. Basically, we're going to be creating a turntable that's kind of like a potter's wheel or like an old record player, and that's what we're looking to build here. Okay, so what we want to do now is we want to have it so when somebody presses the Alt key, that as I move the mouse, it'll tell me the difference in the x coordinate since I've been holding down the Alt. So we want to make sure that the Alt key is being pressed, and the way we know that is because we set up this member variable is Alt pressed. So even though we're in the mouse area, we can still reference that member variable. So what we're going to do here is we're going to say if is Alt pressed. So now we want to do something here. Well, I think what I want to do is I want to compute the distance. So let's do a vector 2, and let's call this distance dragged, and let's make this the start drag position, which was the first time we pressed the Alt key, and we'll have it our current mouse position. Okay, so now we know the distance dragged. We don't really care about the y, so what we're going to do here is say x distance is, and we'll just say is distance dragged dot x. Okay, and let's get rid of this mouse position. Well, let's leave that there. Let's also indent this with a couple of pluses. Yeah. Just so we can visually see it. Those asterisks are just going to scoot it over a little bit, so when we're in our window we can see what it's doing. So if we hit the play button here, so we're getting the mouse position. So I'm going to hold down Alt here, and then I'm dragging the mouse now. Now you notice it's going -50, -60, -80, -100, negative. See how it's the x distance is growing. Now it doesn't really care about the y, but it does care about the x. So the way I'm doing this is as I'm moving forward, it's actually going negative. And we may or may not want that. It really depends on which way we want the thing to rotate as we're moving it around, our mouse pointer around. So I mean, if we wanted it to rotate the other way, we would input invent mouse position, get position minus start dragging position. I'm not sure yet which way we want it to rotate, so let's just leave it like this for now. So we have the input. We have everything we need here to actually capture all of the input from the mouse and the keyboard that we would want. So now all we have to do is actually rotate the actual thing we're trying to rotate. Now here's where it gets interesting. So if you go to Godot here, and so like we want the camera to rotate. Sort of. I mean, what we would like is we would like it so when we're moving our mouse that the whole world, I mean, the camera is moving around the whole world, like we're orbiting around the cube. And if you just rotate the camera, that's not what you're going to get here. You're going to get, the camera like you're looking your head left and right. And that's not what we want. We want to orbit the cube. So then the question is, well, how do you do that? Well, I'm going to demonstrate how we can do that, but then we're not going to do it exactly this way, but we're going to do something very, very close. So if we rotate this, the camera, as it is now, it just looks left and right. And that's not what we want. But what if we took the camera and we made it a child of the cube? So let's go back and preview again. So nothing's really changed. It's still looking the same. And if I rotate the camera even from this position, it's going to do the same thing. You're just going to be looking left and right. However, remember, children inherit their parents' transformations. So this camera is now a child of the cube. This camera is placed a certain distance away from the cube. So one can kind of think of it like, you know, there's you could draw a line between the two, like a rope, and it's that distance away. And it's always going to be that distance away. So if I grab the cube, I wonder what happens if I rotate the cube. What happens? Watch the camera and watch the preview here. Now the cube's still facing us, so this, we don't really want this. The cube always facing us, but watch the floor. That's what gets interesting. And watch the preview here. That is what we want. See how it's rotating around that center point? That's what we want. However, I mean, we don't want the cube itself because the cube is always facing us. So it's like, well, but I want to look around you, cube. So what I think we want to do here, I put the camera back. It's not childed anymore. It's not a child of the cube. But we want something else there that we don't care if it faces us as we move. So what if we just created the most basic 3D element you can and it not actually like have any form? It's just holding space. Well, the most basic form of anything you can do in 3D is a spatial, or at least the most basic that actually has properties we can use here. So what if we take the camera? Oh, by the way, look, the spatial is at 0, 0, which just happens to be about where the cube is. Remember, we lifted the cube up a little bit, so technically the center of the cube is in the middle here. But this is close enough where as we rotate, we're not really going to notice the difference. So what if we took the camera and we made it a child of the spatial? So now if you grab the camera and you rotate just the camera, you know, it's going to do the I'm looking left and right. That's not really all that helpful. But now if you rotate the spatial, look at the preview here. Look at the cube in particular. Well, because we're not rotating the cube, we're rotating a spatial, which we don't care if we can see it or not. Now we're getting exactly what we want. That camera is orbiting around the world here. It's orbiting around the cube. And that's exactly what we want based on, you know, right now I'm moving the mouse and it's rotating based on that amount. It's doing something very similar to what we want to do with the Alt key. You know, in this case, it's storing when I first click this little rotate ring, and then it knows how much I've moved since then, and then it's orbiting around that. So let's put this back here. So what we want to do is, as we move the mouse, as the Alt key's pressed, we want to rotate this spatial. And if we do that, we're going to get what we want. Well, first, let's not call this a spatial, because that's not really telling us what this is. Let's just call this the CameraHelper. And we're going to want to rotate this CameraHelper as the mouse is moving. So let's go back to Writer. So we already know the distance dragged. So we want to rotate that CameraHelper. Well, I don't want to get the I mean, we could do this. Well, basically what we'd want to do is what we did in the ready method. We want to get the node, but instead of getting the cube, we'll be getting that CameraHelper. Well, I don't want to get it every time. The ready method's only called once, but this input is called over and over and over and over again. So let's create another member variable, and it's of type spatial, and let's call it CameraHelper. And then in the ready method, which is only called once, let's actually assign that. Let's do it at the end when we're drawing the wire mesh. Let's CameraHelper equal get node. It's going to be of type spatial, and we are getting the CameraHelper. So as the game first runs, this ready method's called once, and well, it's called once for what we're doing here. And we're assigning the CameraHelper member variable to the node, and this will make it easier just to easily reference this without having to do every single time get node. We'll just be able to reference that variable. So in the event mouse area, now we want to rotate that camera mouse helper. Well, how does one do that? Well, first of all, what do we want to how do we want to rotate it, I guess, is the first question. So we want to rotate it like I was doing here, where I'm dragging this and it's doing this. Well, what axis is that rotating around? And it's this green one, right? I mean, it's not rotating around this axis. It's not rotating around this axis. It's rotating around this one. Well, this is the Y. So we want to rotate around the Y. So I'm going to go ahead and do something here, and then I'll explain a little bit more detail of what I think we need to know here. So fortunately, if we call any spatial, it has a method, has several methods where you can do several rotations. Well, we want to rotate around the y-axis. And as you see in the message here, it says rotates the local transformation around the y-axis by angle in radians. So if one's not familiar what a radian is, this might seem a little bit alien, but just I'll explain a little bit afterwards what a radian is. For our purposes, we don't care. All we care is that its value gets either negative or positive as we move the mouse. I mean, because we're going to be using that x difference to rotate, and we're going to throw in either a positive or negative radian value. And I'll explain what radians are, at least in a generic sense. I'll show a web page that talks about them in a bit. But all we need to know about right now is we're going to be sending into this thing a positive or negative value based on which way we're moving the mouse. So we're going to rotate Y, and well, what are we going to send in here? Well, we want the distance dragged X. However, and I guess maybe this is where radians, I should show that now. So we're probably all familiar with, normally when you're dealing with angles, you're dealing with degrees. So like to go all the way around this circle would be 360 degrees. Well, another way to explain what angle is there is to use something called a radian. And a radian is a unit that is defined as the radius of a circle that you're rotating, and the arc that it's rotating is the same as the radius. And it's going to be easier to understand here. So here's a quick conversion from degrees to radians. And the thing to notice here is that 360 degrees is 2 times pi. And if you remember the circumference of a circle is 2 pi r, this starts to make a little bit of sense. So 2 pi would be 360, so half of that would be 180, and then half of that would be 90. So these numbers, 2 times pi is about 6. So if we just send in this value, the difference in x, like if we're going from an x value, let's go back to Godot to show this. So if we're starting here when we first click the Alt and then we move this much, let's say we move 20, because this will be in pixels. Let's say we move 20. Well, 20 is I mean, if 6.2 radians is one 360 value, then 20, that's 3 revolutions. And that's not what we want. I mean, well, it could be, but that's not really what we want here. We want it to just kind of scoot around a little bit as we're moving. So what we want to do is probably not just use x, but times it by some value that'll shrink it down. And I was playing around, and I think this value is going to work for our purposes. So we're basically going to take the x value, which is, let's say, 100 pixels difference, and we're going to times it by a really small value to give me a really small value, which will be in radians, that then goes to this rotate y. And again, these radians, the value we're sending in, we need to make sure is fairly small. Otherwise, we're going to get giant jumps in the how much we're rotating. Hopefully, I made that clear. It's not so much important that you understand exactly what radians are. You just need to understand that 6 of these turns you around completely. And so, if we're using pixel distance, we can't just use the raw distance, because we'll be doing 6 times around plus a little bit more, and that's not going to be very easy to move around. So then probably the other thing we want to take notice here is, so this rotate y, when you give it this value, it's not an absolute, like a compass heading, go north by northeast at 20 degrees or whatever. It's not telling you absolutely where to go. It's just saying, hey, why don't you rotate a little bit more by this? So because we're doing that, once we do the rotation, we probably want to then recompute the start dragging position, because we've already rotated it. So we don't want, as that value gets, I guess I'll show it here on Godot again. So as we rotate it, we don't, if we start here and then we move here, like that could be 200 or 300. Well, we don't want that value. We just want the distance that has been moved since last time we rotated. So we basically want to recompute the start. After we rotate, we want to recompute the start dragging position. And we could use either one of these. We could either use the get mouse position one that we used up here from the viewport, or we could use the input event mouse. I'm going to use the input event mouse because it already has it. So I'm like, well, why not? And then we should be good. So I'm going to run the game now and see if it actually is going to rotate like we want. I'm hoping, I believe everything here is correct, but you never know. So I'm going to hit the play button. I'm going to be optimistic but cautious. Okay, so now I'm going to hold down the Alt key, and with the Alt key held down, I'm moving the mouse. Check it out. If I move that direction, it moves the cube that way. If I move this direction, it moves the cube the other way. If I let go of the Alt key and just drag it, nothing happens. If I hold down Alt and go up and down, I mean, other than a little bit of left and right that I'm doing by moving up and down, nothing's happening, and I don't want anything to happen. But by holding down the Alt here, and I'm letting up on the Alt, and then, this is exactly what we want. However, we're noticing, because we only have that one directional light, that as we rotate around on the back side of the cube here, that it's dark, and that's not going to be very helpful as we work. So we're going to probably want to add some more lights here. So let's go ahead and close this up, and then let's go back and let's shrink down our preview here so we have more real estate here. So we probably want to add some more directional lights. So that's why I created this node here. And let's create another directional light. And it's going to call it directional light 2, and that's fine. So what we want to do is we want to kind of light up the backside. Yeah. Now remembering from our first video that directional lights don't care in space where they are. It just matters where this red arrow or this yellow arrow is. But I like to have them up just so I can visually get an idea of what's happening. So I want to rotate this yellow arrow so it's going to start illuminating that side. And then we probably need one more light over here. So again, this can go all the way down. It doesn't matter. Directional lights don't care about the position, just the angle of this yellow as a, when it hits the mesh. So we're going to create one more directional light. And we will move it here. Not that it matters where it is, just for bookkeeping. And we'll knock it. I want a little bit of shadow on the cube, just so as we're rotating it, we can kind of get an idea that stuff's happening. So I think, oh, do we need one more? What if we turn this one a little bit? There we go. So it looks like the cube is lit well enough. So then what we want to do here is let's play the game and see how it looks. So hold down the Alt key, rotate. That looks pretty good. I think we can see enough of the mesh. I mean, what I am noticing as we're rotating around is the wireframe we created in the last video is still, I mean, it's still a little bit bigger than we probably want. If you get close enough, you can see there's still kind of like the baggy pants thing going on there. So we probably want to shrink down, use an even smaller number than what we did before. I'm not going to worry about that right now because I think I'm going to end the video here, but I'm also going to say I don't think we're complete yet. I mean, the rotation here I think is great. But I also think the other thing we're going to want is the ability to get closer to the cube and pull away from the cube so we can kind of zoom in. And that by itself I think is going to be a video, because if we decide the way we're going to handle this is just to move the camera, which is probably what I'm going to do, well, we want to make sure that the camera can only get so close. We don't want to get inside the cube. And in fact, we probably don't want to get within a certain distance. So again, I don't know yet, but maybe we'll hold down the control key and move up and down. And as we hold down the control key and move up and down, as we're moving up, we would get closer. But then, like when you get so close, it wouldn't let you get any closer. And the same as if you pulled back, maybe we only want a certain distance where you can back up from the cube, and then it won't go any further. And that's going to be, not an incredible amount of work, but it is going to be a decent amount of work because it's a little bit different than what we're doing now. But the good news is that we do have our key and our mouse area already defined. In fact, what I'm going to do here is I'm going to get rid of these print statements because I don't think we need them anymore. We can always add them again if we want them for debugging purposes. So let's go back here and make sure the rotation works and that nothing's being outputted to the console here. All right, Alt, rotate. Yep, nothing's down here. So fantastic. Okay, so I'm going to end the video here. Next video, I'm going to deal with the zooming in quotation marks, probably just moving the camera in and out. And then after that video, we should be able to start dealing with the mesh itself, which was kind of the whole point of this series, but there was a lot of prerequisite stuff to get put in place here. So thank you for watching, and I will catch you in the next video. Take care.